Hello. In this video, we'll be covering the topic of dimensional analysis, which is really just a fancy way of saying chemistry math. It turns out that we do lots of dimensional analysis in our daily lives without realizing it. The trick for us today is to dig down and see how we can represent mathematically the operations we are doing seemingly instinctively. Once we get a sense of this, we'll develop our general plan of how to do this in the future. Once you have the general plan, you can apply it to all sorts of problems. And since there's no time like the present, we'll apply our plan to some practice problems at the end of this video. Okay, so what is dimensional analysis? Well, like I said before, it's a fancy way of saying chemistry math. Well, what do I mean by that? In math class, we learn to do operations on numbers. We know that 2 plus 3 is 5 and that 14 divided by 2 is 7. In chemistry class, though, we tend to be dealing with measurements. Measurements have both a number and a unit. So in fancy chemistry math, we have to make sure that we're operating on not just the numbers, but also the units. 2 plus 3 is 5, but what is 2 milliliters plus 3 fluid ounces? If we want to add these measurements, we'll have to keep the units in mind as well. If our chemistry guy here wanted to add 2 milliliters and 3 fluid ounces together, he'd want to get both of those measurements in the same unit. So perhaps he'd ask the question, how many milliliters are there in 3 fluid ounces? It turns out that there are almost 89 milliliters in 3 fluid ounces. So in this case, 2 plus 3 equals 91. When our chemistry guy here converted 3 fluid ounces to 89 milliliters, he did dimensional analysis. So dimensional analysis then is a method to convert from one unit system to another based on previously agreed on equalities. For example, chemistry guy from before knew that there are 29.5 milliliters in every fluid ounce. These previously agreed on equalities are all around us. One place that we see them regularly is that we tend to have nicknames for groups of things. So we have a unit for a measure that represents a count of items. We all know that one pair of socks is made up of 2 socks. That is to say, one pair is equal to 2 of something, anything. A pair of socks, a pair of pumpkins, or a pair of pumpkin socks. Likewise, we know that if we go to the store and buy a dozen eggs, we'll come home with 12 eggs. If we wanted a dozen pumpkins, well, you get the idea. So let's give dimensional analysis a try. Here's a big old pile of socks. If I were to tell you that there were 46 socks in this pile, could you tell me how many pairs there were? Well, maybe you just yelled 23 at the screen, and well, that's it. Way to go. But how'd you get there? Well, like our scientist here, you probably divided 46 by 2 in your head, but why? In a heartbeat, you recalled that there is an equality that says 2 of anything is a pair. You use that equality to create what's called a conversion factor, a ratio that's made from an equality. In this case, our conversion factor is the ratio 1 pair of socks over 2 socks. In your head, when you divided 46 by 2, what you really did was multiply 46 by this conversion factor of 1/2. Okay, so let me show you. The question we ask whenever we do dimensional analysis is, how many of the new unit will I have if I start with a certain number of the old unit? Okay, so in this case, our question is, how many pairs are equal to 46 socks? Okay. Pairs are our new units, socks are our old units. So when we multiply by our conversion factor of 1 pair over 2 socks, okay, what happens? Well, we can do this math where we multiply this value times this fraction, and we end up with 46 socks times 1 pair divided by 2 socks. Okay? So look what happens. The unit socks ends up on both the numerator and the denominator. Anytime you have things that show up in the numerator and denominator, when you divide, you end up with 1. So just like you can divide two numbers and get 1, you can divide two units and get 1. So that's to say the units cancel, or you can ignore them, okay? So 46 with no units times 1 pair divided by 2 with no units is going to equal 23. 46 times 1 divided by 2, and then the only unit that's remaining is pairs, okay? So how many pairs are there in 46 socks? Well, there's 23 pairs, okay? So look at this. In dimensional analysis, the goal is to cancel out the units that you don't want and end up with the units that you do want. To get rid of the unit socks, we made sure that the unit socks was in both the numerator and the denominator. All right, so let's try another. Our new question is, how many socks are there in 7½ dozen? So remember, our strategy here is to cancel out the units that we don't want and get to the units that we do want using conversion factors that we happen to know. Well, we remember that a pair is 2. We also know that a dozen is 12. We can use these two equalities to make some conversion factors. Then we can use these conversion factors to get rid of the units we don't want, dozens, and get to the unit that we do want, pairs, okay? So our question here is really asking us two questions. How many socks are in 7½ dozen? And then, how many pairs can we make with that many socks, okay? So let's write our full question first. We say, how many pairs? Pairs is our new unit, are equal to 7.5 dozen, our old unit, okay? So now that we've written out the whole question, let's just try to answer part 1 first, okay? Can we convert from dozen, from the units dozen to the units socks? Well, we have this conversion factor here that tells us that for every 1 dozen socks, we have 12 socks. So if we multiply by this conversion factor here, so 12 socks divided by 1 dozen socks, right? We would have dozen in both the numerator and the denominator. So those two units are going to cancel out when we multiply that number by that fraction, okay? And so our next question then, our second question is, once we're in the unit socks, can we convert that into pairs? Our second question, our old unit becomes socks, which is the unit that we're in right now. Can we convert that to the unit pairs? Well, we can if we multiply by another conversion factor, a conversion factor that tells us that for every 1 pair of socks, we have 2 socks. So if I multiply by that conversion factor and put 1 pair on the top and 2 socks on the bottom, now look what happens. When I do this multiplication, I'll have socks in the numerator and the denominator. If I divide a number by the same number or divide a unit by the same unit, that cancels out and I can ignore them. That becomes 1, okay? So now, by multiplying by these two conversion factors, I've been left with just 1 unit, the unit pair, okay? And pair is what I wanted. I was looking to find how many pairs are in 7½ dozen. So now that I've followed the units through and I have only the unit that I'm looking for, it's as simple as working through the math. And so the math says that I'll take 7½ dozen and multiply it by 12, and then I'll divide that number by 1, which just gives you that same number. And then I'll multiply that number by 1, which again just gives you that same number, and then I'll divide by 2, okay? So it's 7½ times 12 divided by 2, all right? So let's take a look. Let's do that calculation. All right, so we're starting with 7.5 dozen. We multiply that by 12. That equals 90, okay? So in 7½ dozen, there are 90 socks, and then I'm going to pair those socks by dividing by 2, okay? So the answer there is 45. So how many pairs are in 7½ dozen? It's 45 pairs, okay? And so again, what we did was use unit conversions. We used equalities that we happen to know, okay, to allow us to go from the unit that we started with, the unit we wanted to get rid of, to get to the unit that we wanted. All right? Okay, so really dimensional analysis comes down to this guiding principle. Always think of the unit as just another number. To get rid of the unit, you make sure that that same unit is on both the top and bottom of a fraction. Inches divided by inches equals 1 the same way that 7 divided by 7 equals 1. To do this math, we need to know where to find equalities that can help us move toward the unit that we want and away from the unit that we don't. As we saw in the last example, sometimes you can't do that in just one step. Okay, so let's try another multi-step problem. The question here is, how many seconds are there in a day? Well, maybe you happen to know that one in your head, but maybe you don't. Okay, so if you don't happen to know that, like me, you can start thinking about some equalities that you do happen to know concerning days and seconds and so on. All right, so let's write some. Well, we know that there are 60 seconds are equal to 1 minute. We know that there's 365 days in a year. We know that there's 7 days in 1 week. Okay, I should probably write a 1 by that year. Let's see, minutes. We know that there's 60 minutes in an hour. Okay, in 1 hour. We know that there's 24 hours equal to 1 day. Let's stop there. Let's see if that's enough to get us from where we started to where we want to be. Okay, so the question is, can I use some of these equalities to help me get away from days and towards seconds, right? The question, okay, the question that we're asking is, how many seconds are equal to 1 day? Okay, so we're trying to get from the units days to the unit seconds. Well, I know that a second is a lot less time than a day. So if I want to move from days to seconds, I want to start converting days into smaller chunks of time. Okay, so that means that 365 days in a year and 7 days in a week, those don't really help me because they convert days to an even bigger chunk of time. However, some of these other units do convert days into smaller chunks of time. In fact, this one here converts days into the smaller chunk of time of hours. Okay? All right, so I can, right, convert to hours to cancel the unit day using this particular equality, right? And once I've done that, once I've converted to hours, I can convert hours to a smaller chunk of time by canceling the unit hours to convert to the unit's minutes. Right? I can use this equality here. And then once I'm in the unit's minutes, I can convert that to an even smaller unit. I can convert to seconds by canceling the unit minutes by using this equality here. Okay? So once I make that conversion, I'll be in the unit seconds, right? So I'm converting from days to hours, from hours to minutes, and from minutes to seconds. So this is going to be doing 3 conversions in order to get from the unit that I want to get rid of, days, and get to the unit that I want, seconds. All right, so my overall question, again, for dimensional analysis was to say, how many seconds are equal to 1 day, right? And let me just remember here that to convert from hours to days, I'm going to need the equality that 1 day is equal to 24 hours. To convert 2 minutes from hours, I'm going to need the equality that 1 hour is equal to 60 minutes. To convert from minutes to seconds, I'll need to remember that in 1 minute, there are 60 seconds. Okay? And for each of these equalities, I want to turn them into a conversion factor. And so remember, the purpose of that conversion factor is to convert from the unit that you don't want to the unit that you do want. And to get rid of that unit that you don't want, you're trying to make sure that it's in both the numerator and the denominator of what you eventually multiply together. So in the first step, I'm going to multiply by a conversion factor. And since right now days is in the numerator, I'm going to want to make sure that days ends up in the denominator. Okay? So when I convert 2 hours from days, the conversion factor that I want is to have days in the denominator so I can get away from it. And then have hours in the numerator because that's what I want to get to. Okay, that's the unit that I want to go to. So I'm going to put the unit hours in the numerator. And I know that there are 24 hours in one day. Okay, so the units day and day cancel and I'm left with the units hours. So I've made it from here to here. My next step then is to use this equality to convert 2 minutes from hours. Right now, hours is in the numerator. So in my next fraction, I'm going to want to make sure that hours is in the denominator. Well, I know that 1 hour is equal to 60 minutes. Okay? That allows the units hours in the numerator and hours in the denominator to cancel. And so now I'm in the units minutes. I've converted from hours to minutes. My last step then is to convert from minutes to seconds. I've got minutes in the numerator here. So in my next fraction, I want to make sure that the unit minute is in the denominator. Well, I know that there are 60 seconds in 1 minute. So now the unit minute and minute will cancel because it's in the numerator and the denominator. And look what's happened. The only unit that I have left is seconds. And that's the unit that I wanted. I was trying to go from day to seconds. I had to go through hours and minutes in order to get from days to seconds. Okay? So now that I'm certain that all of my units have canceled, the only thing left to do is to do that math. So I'll take my original measurement, 1 day, okay? I'll take the 1 and multiply it by 24, which gives me 24, and I multiply that, or divide that by 1, and I still have 24. I'll then take that and multiply it by 60. That product I'll divide by 1, which is just the same number, and then I'll take that number and I'll multiply by 60 again, and then I'll take that product and divide again by 1, which is just that same number. So I'm going to take 1, multiply it by 24, multiply it by 60, and then multiply it by 60 again. Okay, so let's give that a try. All right, so I'm starting with 1, and then I'm multiplying it by 24, and then I'm multiplying that by 60. And then I'm multiplying that by 60 again. Okay? So 1 times 24 times 60 times 60. That equals 86,400 seconds. Okay? How many seconds are there in one day? There are 86,400 seconds. All right. So far we've been converting measurements that have just 1 unit. So what if our measurement actually has 2 units, right? Say the value that we want to convert is some unit per some other unit, okay? A good example to think about is speed, right? So here in the United States, we use miles per hour. That's distance per time, okay? In other parts of the world, the common measurement of speed is kilometers per hour. We can see in this speedometer both units of measure are shown. We can see that, well, 60 miles per 1 hour is about equal to 100 kilometers per 1 hour. Okay? So let's ask a question here, okay? In which we have to convert both distance and time in a speed question, okay, in a speed measurement, right? So let's say our question is this: how many kilometers per minute are there in 80 miles per hour? Okay, so to do our dimensional analysis, we're going to need to convert our distance unit from miles to kilometers and our time unit from hours to minutes. Well, no problem. We can do this stepwise. Okay, so In the first step, we'll convert 2 kilometers to cancel out miles, and in the next step, we'll convert from hours to minutes. Remember that in each case, we'll want to make sure that the unit we're trying to get rid of, miles and hours, show up in both the numerators and the denominators of the fractions that we'll end up multiplying. Okay? So we'll need some equalities that we can turn into conversion factors. Well, we already know, okay, that there are 60 minutes in an hour, all right? We already know that there's 60 minutes in an hour. I don't happen to know offhand how many miles are in a kilometer, but luckily we have lots of resources available to us. If we do a web search, what we find is that there are 0.62137 miles in 1 kilometer, right? Okay, 1 kilometer is 0.621371 miles, okay? All right, so now, as always, I'll write my question as I wrote it before, right? I'm gonna ask how many kilometers per 1 minute are equal to 80 miles per 1 hour, okay? So notice, before, it's a little different than before, right? Before we were always just writing this, how many of this unit is equal to this unit. Well, I'm doing the same thing, right? But now I'm writing a fraction. So, okay, let's start with, let's convert 2 kilometers from miles. Well, in this first step here, right, I have miles in the numerator. So that means if I multiply by a fraction, I'm going to want to make sure that miles ends up in the denominator so that those 2 units will cancel. So I know that there is a conversion between miles and kilometers. I know that 1 kilometer is equal to 0.621371 miles, okay? That's going to allow miles on the top and miles on the bottom to cancel. So right now, what units do I have? I have kilometers per hour, okay? And so if I were to do this calculation, take 80 and divide it by 0.62, I'd get something right around here. I'd get around 130 kilometers per hour. But the question we were asked is kilometers per minute. So my next step is to convert hours into minutes. Well, look, right now, hours is in the denominator. So that means that when I multiply by a conversion factor to allow me to convert from hours to minutes, I need to this time make sure that hours is in the numerator, okay? So that when I multiply, hours ends up in both the denominator and the numerator. Well, I happen to know that in 1 hour there are 60 minutes, okay? So since hours is in the denominator and in the numerator, those units cancel. So look what units I have left. I've got kilometers per minute, okay? Kilometers in the numerator, minutes in the denominator. So I've got the units that I wanted. I wanted to know how many kilometers we were driving per minute if we're driving 80 miles per hour, okay? So now it's just a matter of doing the math. So the math says that I want to start with my 80 miles per 1 hour, divide that by 0.621371, right? I'll take 80, multiply it by 1, which will still be 80, and then I'll divide by this 0.62, which is going to give me a number somewhere around 130. And then I'm going to take that number and I'll multiply it by 1, which will still give me around 130, and then I'll divide it by 60, okay? So that's my plan, all right? So let's give that a try. So I'm starting with 80, and then I'm going to divide that by 0.621371, right? And if I go ahead and hit equal here, okay, I get 128 kilometers per hour, right? We were pretty close. And now my next step, I can just go ahead and multiply by 1, right? And I still have that same number. and then I can divide by 60, and now I'm in the units of kilometers per minute. So how fast am I driving? If I'm driving 80 miles per hour, I'm driving around 2 kilometers per 1 minute, right? Remember, these units here, miles per hour, are miles per 1 hour, right? And it's kilometers per hour is kilometers per 1 hour, right? So that's why here I wrote kilometers per 1 minute and miles, 80 miles per 1 hour, right? The 1 in mph is understood. The 1 in kilometers per hour is understood. It's per 1 hour, okay? All right, so what did we learn today? Well, we learned that dimensional analysis is a way to convert from one unit system to another. It basically just asks us to remember to operate on units the same way we operate on numbers. We found we can cancel units out by making sure that they show up in both the numerator and the denominator of the product of our starting unit and conversion factor fractions. I hope this video was helpful. I hope you'll leave some feedback in the comments section below. I'd like to make more of these videos and would love to hear how to make them even more useful. Not ready to quit just yet? Well, excellent. Let's move on to some practice problems. Here's a pro tip. Once you see the question, pause the video and try to work it yourself before watching the solution. Just so you know, there's 5 practice problems ahead. Not sticking around for the practice problems? That's okay. Stop by again sometime. All right, our first practice problem here is how many inches are there in 3.6 feet? Well, just like always, we're going to start by writing out our question. Our question is, how many inches are equal to 3.6 feet, okay? And so in order to convert from feet to inches, I'm going to need some equality or equalities that relate feet to inches. Well, I happen to know a good one. I know that there are 12 inches in every 1 foot, okay? So I can use that equality to let me convert from feet to inches, okay? So I can multiply by a conversion factor that is going to allow me to cancel feet. Since feet is in the numerator here, I need to make sure it's in the denominator here. Well, if feet's in the denominator, that means that inch will be in the numerator. And so the numbers here are that 1 foot is equal to 12 inches. So feet and feet will cancel. The only unit that I have left is inches. And so now it's just a matter of doing the math. It's 36 times 12, okay? So let's go ahead and type that in our calculator. I'm sorry, not 36, it's 3.6. Oh geez, 3.6 times 12, okay? And so that equals 43.2, okay? So let me slide this out of the way. So it was 3.6 times 12. So how many inches are there in 3.6 feet? There are 43.2 inches. Okay. All right. Well, let's move on to another one. So the next one, how many centimeters are there in 3.6 feet? Okay. In this one, well, first of all, our question is how many centimeters are there equal to 3.6 feet, okay? Well, now we're going to need some way to convert between feet and centimeters. I don't happen to know a conversion factor that's going to allow us to go directly from feet to centimeters, but I do know, like before, there are 12 inches in 1 foot. And I happen to know another conversion factor, or you could sure look this up in a web search, but I know that there are 2.54 centimeters in every 1 inch, okay? So this is a defined way to be able to convert from the English unit system to the metric unit system, okay? And so look here, I'm starting with feet and I'm trying to get to centimeters. Well, I can convert from feet to inches using this conversion factor. I just did it in the last problem. And now I can use this second conversion factor to allow me to convert from inches to centimeters. Okay? So I'm going to start with my 3.6 feet, and I'm going to multiply by a conversion factor that has feet in the denominator so that I get rid of the unit feet. Well, I've got this conversion factor here that would put inch in the numerator. The numbers there are that 12 inches is equal to 1 foot. Feet in the numerator and the denominator will cancel, and so the units that I'm left with now are inches. We remember from our last problem that 3.6 times 12 is 43.2. Okay, the units are inches. And so now I can multiply that by another conversion factor that's going to convert from inches, which I have in the numerator. So I'll want to put it in the denominator of my next conversion factor. And it'll have centimeters in the numerator. That's the unit that I'm trying to get to. So the numbers there are that there are 2.54 centimeters in every 1 inch. Well, inches in the numerator, inches in the denominator cancel, and so the only unit that I'm left with is centimeters. Okay? And that's the unit that I'm looking for. How many centimeters are there in 3.6 feet? So my math here is to take 3.6, multiply it by 12, and then divide it by 1. Right, which is still 3.6 times 12, or 43.2. Then I'm going to take that and I'm going to multiply it by 2.54, right? And I can divide that product by 1, but it'll still just be that same number. So my math is 3.6 times 12 times 2.54. Okay, so let's do that. So we've got, So we've got 3.6 times 12 times 2.54. That equals 109.728. Since my original number only had 2 significant figures, I'm just going to keep 2 in my answer. So I'm going to say that it's about 110 centimeters. Okay? So how many centimeters are there in 3.6 feet? It's about 110 centimeters, right? Okay, our next problem here asks us how many liters are there in 6.8 gallons? Okay, how many liters are equal to 6.8 gallons? Well, you may not know a conversion factor for this, so you might need to do a web search. I happen to know it because I like to drink milk and I buy gallon containers of milk. And on that gallon container of milk, it always says how many liters are in that same container. And so I know just from drinking milk that 1 gallon is equal to 3.78 liters. Okay? So now I have a conversion factor that's going to allow me to go directly from gallons to liters, right? So I just need one conversion factor here. I'm trying to cancel out the unit gallons, so I'm going to want to put that in the denominator since it's in the numerator here. And then I'm trying to get to the unit liters, so I'll make sure that that's in the numerator. So the numbers are that there are 3.78 liters in every 1 gallon. Gallons in the numerator and the denominator cancel, and so the only unit that I'm left with is gallons. So now I just need to do the math, which is going to be 6.8 times 3.78, and then we'll divide that product by 1, which is, again, just the same number. Okay, so let's do that math. So we'll take 6.8, and we'll multiply it by 3.78. And the answer that we get there is 25.704, and that's in liters. Since our original number just has 2 significant figures, let's just keep 2. So we'll say that 6.8 gallons is about 26 liters. Okay? So how many liters are there in 6.8 gallons? It's 26 liters, or thereabout. Okay? All right, here's another one. How many kilograms are there in 6.8 pounds? Okay? Well, you could certainly look up what 1 kilogram is in pounds by doing a web search. And because I didn't happen to know that one offhand, I went ahead and looked it up. Okay? And I saw that 1 kilogram is equal to 2.20462 pounds, or, oops, lbs, okay? All right, so our question then was how many kilograms are equal to 6.8 pounds? Well, I have a conversion factor that will allow me to convert directly from pounds to kilograms. So I'll multiply by a conversion factor that puts pounds in the denominator because I've got pounds in the numerator here. So that means that kilograms goes in the numerator. And so the numbers are that 1 kilogram is equal to 2.20462 pounds. Okay? And so I can do that math directly. 6.8 times 1, which is still 6.8, and then divided by 2.2. Well, let's do it one other way, okay? Let's say we weren't able to find this conversion that allowed us to go directly from pounds to kilograms, okay? Maybe you happen to know some other conversion factors, okay? I happen to know one that says that there are 453.6 grams in 1 pound, okay, 1 pound, right? And I happen to know that there are 1,000 grams in 1 kilogram, okay? So now I can solve the same problem by doing it in 2 steps rather than by doing it in 1. So my question again is still how many kilograms are equal to 6.8 pounds, okay? I can multiply by my first conversion factor. Since pounds is in the numerator here, I'm going to want to get it in the denominator here, and that means that my unit will be grams in the numerator. So it's going to be 453.6 divided by 453.6 grams divided by 1 pound. That'll allow the units of pounds and pounds to cancel, and now my unit is grams. Well, I also know that there are 1,000 grams in 1 kilogram. Grams in the numerator, grams in the denominator cancel, and so now the only unit that I have left is kilograms, which is the unit that I want. How many kilograms are equal to 6.8 pounds? So in this way of doing it, I'm taking 6.8 and dividing by 2.2. In this way of doing it, I'm taking 6.8, multiplying it by 453, and then dividing by 1,000. Either way should give me the same answer. Well, let's prove that to ourselves, that we can get the same answer both ways. So in my first way of doing it, I'm going to take my 6.8 and divide it by 2.20462. And the answer that I get is 3.08. Okay? My original measurement just had 2 significant figures, so I'm going to round this off to 3.1. So this says there are 3.1 kilograms in 6.8 pounds, right? Let's try it the other way. Our other way of doing it was to start with 6.8, and then we're going to multiply that by 453.6, okay? That equals 3,084, and then we're going to take that and divide it by 1,000. And what we get is 3.08448. Remember, our original measurement just had 2 significant figures, so we want our answer to have 2 significant figures. So 3.08448 will round up to 3.1, okay? So in both cases, we figured out that there are 3.1 kilograms in 6.8 pounds, okay? In this way, we did it in 1 step. In this way, we did it in 2 steps. The trick is always the same. You want to get from the unit that you start with to the unit that you want to end with, okay? As long as you're using real equalities, real conversion factors, you can do this same calculation in lots of different pathways. All right, let's try just one more. Here's one that's a little tougher, right? So light travels at 300 billion meters per second, okay? I'm sorry, 300 million meters per second, okay? That's still pretty fast, okay? What is this value in miles per hour, okay? So our question here, the question we're going to ask is how many miles in every 1 hour does light travel if it's traveling at 300 million meters in every 1 second? Okay, so I'm going to need just a couple of conversion factors, a couple of equalities that's going to allow me to convert from meters per second into miles per hour. Okay, well, here's some that I happen to know. I know that there are 1,000 meters in 1 kilometer. Okay, and that's an important conversion factor for me because I happen to know that there are 0.621371 miles in every 1 kilometer. Remember, we used that conversion factor earlier. Okay, so converting meters to kilometers is important so that I can convert from kilometers to miles, right? That's where I want my distance unit to go, from meters to miles. My time unit, I want it to go from seconds into hours. So I'm going to need some conversion factors there as well. Well, I happen to know that there are 60 seconds in every 1 minute. And we also know that there are 60 minutes in every 1 hour. Okay, so I can use those two conversion factors to allow me to get from seconds to hours, right? Let's do our distance unit first here. So I'm going to multiply by my first conversion factor to go from meters to kilometers. So I'm going to want to have meters on the bottom, kilometers on the top, because here meters is on the top. So it's 1 kilometer is equal to 1,000 meters. So meters and meters cancel. And so now the unit that I'm in is in kilometers per second. Okay. Now I can convert that from kilometers to miles. So my next conversion factor will have kilometers on the bottom because kilometers is on the top here. And so that puts miles on the top, right? And it's this very long number, 0.621371 miles is equal to 1 kilometer. Kilometers on the top, kilometers on the bottom cancel. And so now my units are miles per second, okay? So I've got my distance unit in the right unit. So now I just need to work on my time unit, okay? The first thing I'm going to do is convert from seconds to minutes using this equality. Since seconds is on the bottom and I'm trying to cancel it, I'm going to want to put seconds in the numerator, right? So that it's in both the denominator and the numerator. If seconds goes in the numerator, that means that minute has to go in the denominator. And so I know that there are 60 seconds in 1 minute, okay? So seconds on the bottom, seconds on the top cancel. And so now what are my units? They're miles per minute, okay? Well, I don't want to be in miles per minute. I want to be in miles per hour. So I need one more conversion factor. Since minutes is on the bottom here, I'm going to want to make sure that it's on the top here, okay? And that means if I'm using this conversion factor, I'll put hours in the bottom. And I know that there are 60 minutes in one hour, okay? So that means that minutes in the denominator and minutes in the numerator cancel. And so now what are my units? Everything on the top is canceled except for miles. Everything on the bottom is canceled except for hours. So it's miles per hour. And those are the units that I wanted, okay? So now it's just a matter of doing the math. I'm ignoring the ones because I know that they don't do anything to the calculation. They leave it the same. But it's 300 million divided by 1,000, multiplied by 0.62, multiplied by 60, multiplied by 60. Okay, so let's try that math and see what we turn up with. Okay, I'll move this over here so it won't block what we're doing. Okay, so remember, I'm starting with 300 million. Okay, oops, that's 3 billion. 300 million. Okay, my first step then is to divide that by 1,000, and then I'm going to multiply by 0.621371, and then I'm going to multiply by 60, and then I'm going to multiply by 60. And that gives me 671,080,680. Okay. All right. And so that's our answer there. And remember, that answer is in miles per hour. Okay. Well, oops. That's the end of our video. I hope this was really helpful for you. And again, if there's anything I can do to make future videos more helpful, please leave some comments below. And I ask that you stay tuned for more chemistry skills. All right. Hope you have a good day.